Welcome, star fans. Have you ever imagined witnessing a galactic event so grand that it casts shadows across Earth? This rare phenomenon might be closer than we think. In the Orion constellation, the star Betelgeuse is exhibiting unusual behavior, hinting at an impending cosmic event that could light up our skies like never before. But when exactly will Betelgeuse explode, and what will this celestial spectacle look like? According to scientists, this explosion could reveal profound cosmic secrets. Join us as we explore the mysteries surrounding Betelgeuse and the potential effects this event may have on Earth and the entire solar system. Located approximately 650 light-years away in the Orion constellation, Betelgeuse is not just any ordinary star. It is a red supergiant, one of the most luminous stars we know, shining with a brightness over 100,000 times that of our Sun. But why is this massive star so important to us? Beyond its brilliance, Betelgeuse holds deep cultural significance. Its name originates from the Arabic term Yad al-Jawza, meaning the hand of Orion. This star has been observed and recorded by ancient civilizations for centuries, guiding explorers and fascinating astronomers with its distinct red tint, which sets it apart from other stars in the constellation. Imagine a single star so enormous that it could dwarf our entire solar system. To give some perspective, if Betelgeuse were to replace our Sun, its outer edges would extend all the way to Jupiter. How does a star achieve such titanic proportions? At around 10 million years old, Betelgeuse is much younger than our 5-billion-year-old Sunday. However, its immense size causes it to consume fuel at a much faster rate, resulting in a much shorter lifespan compared to other stars. This stellar giant, possessing a volume large enough to house over 1 billion suns, is approaching the end of its life cycle. When stars of this size reach their twilight years, they don't simply fade away. Instead, they go out as supernovae, explosive events of unimaginable energy and brightness. These kinds of explosions can outshine entire galaxies, casting light that stretches across vast cosmic distances. The last time Earth witnessed such a nearby stellar explosion was in 1604, before the advent of modern telescopes. The Kepler supernova, visible for over 18 months, was the most recent supernova observed in the Milky Way. It was so bright that it rivaled other stars in the night sky and remained visible even during the daytime for weeks. What hidden insights do these celestial remnants reveal? Ancient records from civilizations, including Chinese and European astronomers, documented the appearance of new stars, providing us with valuable knowledge about the violent ends of massive stars. The remnants of these explosions, observed today as expanding clouds of debris, continue to offer critical information about the catastrophic endings of supergiant stars. While supernovae have been rare sights for observers on Earth, imagine an event so powerful that it rivals the brightness of the full moon, casts shadows on Earth at night, and might even be visible during the daytime. The radiation emitted by such an event would be so intense that it could ionize our atmosphere, potentially disrupting satellite communications and even affecting Earth's weather. Betelgeuse, with its erratic dimming patterns, seems to be preparing for such a dramatic event. Could we be on the verge of witnessing one of the most extraordinary events in the universe? Between October 2019 and mid-2023, Betelgeuse underwent a remarkable transformation that captured the attention of astronomers and stargazers alike. Known as the Great Dimming, this change in the star's brightness, which had been relatively stable for decades, began to decline drastically. This sudden dimming was noticeable enough that even casual observers could see the difference when comparing Betelgeuse to other stars in the Orion constellation. This suggests that we may not be centuries away from witnessing Betelgeuse's supernova. It could happen within the next few decades, or perhaps even sooner. By April 2023, astronomical observations indicated that Betelgeuse had returned to its normal brightness levels, leading many to believe that the dimming period had ended. In a surprising twist, over the following months, Betelgeuse's brightness surged by an unexpected 50%. While fluctuations in brightness are normal for variable stars, such dramatic changes are highly unusual for a star like Betelgeuse, which typically exhibits consistent patterns of luminosity. This sudden increase in brightness thrust Betelgeuse back into the spotlight, raising questions about what caused these unexpected changes. Why did this once predictable star suddenly experience such dramatic fluctuations? Stars are not just fixed points of light in the night sky. They are dynamic, evolving entities with life cycles, behaviors, and mysteries of their own. For most stars, changes in brightness occur in predictable patterns, much like the seasons on Earth. Betelgeuse had maintained a relatively steady 400-day brightness cycle throughout much of its existence. However, with the Great Dimming, it appeared to defy this established pattern, challenging our understanding of stellar phenomena. You might be wondering, are we on the brink of a cosmic revelation? While the exact reasons for Betelgeuse's irregular behavior remain under investigation, a fascinating theory has emerged. This hypothesis involves stellar activity and mass ejection, presenting an intriguing scenario. Imagine Betelgeuse as a massive volcano, quietly releasing vast amounts of its material into space. Past observations from the Hubble Space Telescope revealed that Betelgeuse had ejected a massive amount of material from its surface into the universe. This eruption, a spectacular event, involved approximately 400 billion times the mass typically expelled by similar solar phenomena, equivalent to several times the mass of our Moon. Such events can lead to the formation of a thick dust cloud around the star, temporarily reducing its apparent brightness and making it harder to observe. As this dust cloud dissipates or is driven away by the star's radiation pressure, the star's true brightness is revealed once again. These recent developments suggest a star that isn't done surprising us yet. Many speculate that Betelgeuse is nearing the end of its life. But what exactly is a supernova? A supernova is an explosive burst of energy that can outshine an entire galaxy. This event occurs when a star undergoes a sudden collapse at its core, triggered either by the accumulation of matter from a neighboring star or, in Betelgeuse's case, the depletion of its nuclear fuel. As this fuel runs out, the star's mass collapses inward, setting the stage for a catastrophic explosion. Stars like Betelgeuse are born from the gravitational collapse of gas and dust clouds in space. They begin their lives by fusing hydrogen into helium at their cores, a stage known as the main sequence. This phase, which lasts billions of years, forms the foundation of a star's life cycle. As hydrogen reserves are depleted, the star transitions to fusing helium and eventually progresses to heavier elements like carbon and oxygen. For Betelgeuse, this transition has led to the formation of increasingly heavier elements in its core. Ultimately, when iron forms at the core, it becomes impossible to generate enough energy to counteract the pull of gravity. This leads to a collapse and, eventually, a massive explosion, a supernova. Research from Japan's Tohoku University suggests that Betelgeuse may already be in its carbon-burning stage, with its core possibly collapsing within the next few years. However, not all experts agree. Studies from Hungary's Konkoly Observatory propose that Betelgeuse is still in the earlier helium-burning phase. Despite these differing opinions, one thing is certain: Betelgeuse is destined to become the next supernova in the Milky Way. But when will this happen? The timing remains an ongoing mystery, with estimates ranging from a few decades to as far as 100,000 years into the future. While scientists debate the exact timeline of Betelgeuse's demise, one undeniable truth remains: when it happens, it will be a truly extraordinary event. As we contemplate the potential for such a cosmic explosion, it's important to consider the broader implications of such an event on our cosmic neighborhood. When Betelgeuse reaches the end of its life, the shock waves produced by its supernova will influence the surrounding interstellar medium. These shock waves will create vast regions of ionized gas, enriching space with heavier elements formed during the star's lifetime. This process plays a crucial role in the ongoing cycle of star formation and planetary creation. Additionally, the light from Betelgeuse's eventual explosion could serve as a natural laboratory for astronomers studying the life and death of massive stars. By analyzing the light curves and spectral features of the explosion, scientists can gain valuable insights into the physical processes that occur during such cataclysmic events, refining their models of stellar evolution. Beyond the scientific impact, a supernova could have profound cultural and social effects. Throughout history, celestial events have inspired artists, writers, and philosophers to ponder humanity's place in the universe. Betelgeuse's potential explosion could spark a new wave of creative expression, as people around the world gaze up at the night sky in as the world watches and waits. The potential explosion of Betelgeuse would not only be a visual spectacle but also a monumental scientific opportunity. Modern observatories, equipped with advanced instruments, are poised to capture the event in unprecedented detail. From ground-based telescopes to space observatories like Hubble and James Webb, astronomers will be able to study the phenomenon in real time, providing insights that could reshape our understanding of stellar death and supernova physics. When Betelgeuse finally goes supernova, the brightness could rival or even surpass the full moon, making it visible during the day for weeks or months. The night sky will transform into a cosmic stage, with Betelgeuse shining as a brilliant, temporary beacon. This event will not only captivate stargazers but will also mark the first nearby supernova to occur during the era of modern science, offering an unprecedented chance to observe the aftermath. The supernova's shock waves will have ripple effects across the cosmos. The materials ejected by the explosion, elements like carbon, oxygen, and iron, will enrich nearby interstellar clouds, seeding the galaxy with the raw ingredients for future stars and planets. These heavy elements, forged in the heart of stars like Betelgeuse, are essential for the formation of rocky planets and even life itself. In this sense, the death of one star lays the foundation for the birth of others, a cosmic cycle of creation and destruction. But what about the potential risks? Could a supernova so close to Earth have harmful effects? Fortunately, at a distance of approximately 650 light-years, Betelgeuse is far enough away that its explosion poses no direct threat to our planet. While the burst of radiation, especially gamma rays, will be intense, it is unlikely to significantly impact Earth's atmosphere or life. However, sensitive satellite systems and space-based technology could experience disruptions from the influx of high-energy particles. For astronomers, Betelgeuse's supernova represents a chance to unravel mysteries that have puzzled humanity for centuries. By studying the event, they hope to answer critical questions. What triggers a supernova precisely? What is the role of stellar mass loss in the final stages of a star's life? How do supernovae influence the larger structure of galaxies? In the meantime, Betelgeuse continues to keep scientists guessing. While its recent dimming and subsequent brightening have sparked speculation about its imminent demise, stars of this size often exhibit unpredictable behavior. It's possible that Betelgeuse still has thousands of years left before its dramatic end. But whether it happens tomorrow, in a few decades, or far into the future, one thing is clear. Its supernova will be a once-in-a-lifetime event that will leave an indelible mark on both science and culture. Until that day comes, Betelgeuse serves as a powerful reminder of the vast, dynamic universe we inhabit, a universe filled with wonders yet to be discovered. For now, we look up at the Orion constellation, marveling at the star that holds the promise of a future cosmic spectacle.